Assalamualaikum and hello everyone. My name is Nurul Farhatina Jobindi Rosali. Today I would like to present my final year project entitled A Review on Removal of Heavy Metal, Cadmium and Nickel Solution Using Eggshells as Activated Carbon. This project was supervised by Mr. Zulkifli bin Osman. So for a bit of background, water is essential for us in various purposes like drinking, bathing, and so on. According to E. Al-Khatib et al. 2016, heavy metals accumulated in water or wastewater are indeed possess threats to human health and the environment as well. According to Liu W. et al. 2017, there are several potential methods in order to ensure the cleanliness of water and wastewater, which include ion exchange and adsorption. However, the current research are focusing on using household waste as an adsorbent because adsorbent can be so expensive depending upon the materials used. Eggshells are chosen as an adsorbent because they have an excellent characteristic such as porosity, which enables them to captivate the desired heavy metals during adsorption process. Now let's talk about the problem statement. The problem associated with water pollution is still ongoing. This is clear that we are still lacking awareness in order to ensure the cleanliness of our water resources. The study nowadays was more focusing on finding an alternative way to use agricultural, industrial, or household waste so that the increasing waste in dumping sites can be reduced. Now, for the significance of the study will be beneficial in determining the accuracy of eggshells as the activated carbon using scanning electron microscope, SEM, and Fourier transform infrared spectroscopy or FTIR. It is also to address the growing problem of eggshell waste disposal in landfills. This study is also to explain both models involved in the adsorption processes, which are Langmuir and Freundlich. Now for the objectives of the study was done and conducted in order to review the characteristics of eggshells by using scanning electron microscope, SEM, and to review the functional group present in eggshells by the use of Fourier transform infrared spectroscopy or FTIR. Now we are in chapter 2, which is literature review. For adsorption process, according to Burakov PE et al. 2018, when one substance adsorbs another, for example, heavy metals contaminants are captivated by the adsorbent material, that process is called adsorption. According to Suhas et al. 2016, this process is versatile when it comes to the design and also the operation, thus lead to the production of quality and better effluents. According to Wang J and Guo X 2020, chemical adsorption isotherm is the adsorption model in which the adsorbate ions are captivated in the adsorption spots of an adsorbent. The common examples of chemical adsorption isotherm are Langmuir and Wolmer isotherm models. According to the same authors, physical adsorption isotherm imitate the heterogeneous layer adsorption process. The uttermost force of physical adsorption is van der Waals force. The examples of physical adsorption isotherms are Brunner, Emmett and Taylor, or BET, and Johannisch isotherm models. Now we will talk about activated carbon. According to Reynaud et al. 2017, activated carbon is porosity with a slit shape and the size of molecules that is surrounded by a carbon atom. The coal, coconut shell, hardwood, fruit stones, and synthetic molecular systems are all used to make activated carbon. According to the same authors again, because of its wide area of surfaces, pore spaces, and different functional groups contain oxygen on the surface, activated carbon is an excellent adsorbent. According to Burakov AE et al. 2018, physical and chemical activation agents are two types of activation agents available. According to the same authors, chemical activation has been known to be more efficient in preparation of activated carbon with excellent pores as compared to the physical activation method. The use of coal-based carbon is limited as it is expensive. As a result, more attempts have been made in order to transform household waste into activated carbon because they are easy to get and also inexpensive. Now, let's talk about heavy metals. According to Liah and Sadlicki 2017, extremely high amounts of cadmium result in unbound and free CD, resulting in hazardous effects. According to Kim et al. 2020, CD can cause cancer to humans as a result of long-time exposure to this heavy metal. According to Nishijo et al. 2017, the widespread of CD contamination on food and water supplies has caused Ita illness outbreak in Japan. Last but not least, according to Wu et al. 2019, oxidative stress may occur as a result of CD interfere with the antioxidant glutathione. Now for the properties of eggshells, according to Mittal et al. 2016, eggshells consist of 3 layers. The first one is the cuticle, which is the outermost layer surrounding the eggshell. The layer beneath called the testa or the shell. And last but not least, the mammillary layer, which is the innermost layer. According to Creedy and Pliapi, 2019, researchers tend to heat eggshells at various extreme temperatures, and those eggshells were examined under a scanning electron microscope to acquire a greater grasp of the stratified composites of a hen eggshell. According to Betancourt and Creedy, 2017, researchers contrasted scanning electron microscope pictures of eggshell with mineral limestone powders at the same magnification and found that eggshells have pores, while limestones does not. Now let's move on to the development of eggshells as an adsorbent. According to Borhade AV and Kale AS 2017, because of its strong ion exchange ability, employing eggshell as an adsorbent for water contaminants is a thoughtful endeavor. Next, according to Buasri A et al. 2015, calcination is a thermal treatment in which the particles breaks down from the primary component of calcium carbonate into calcium oxide. Besides that, according to HUD A 2020, the surface area and the pore volume of powdered eggshells increases as the calcination temperature rises. Last but not least, according to Laskarbi et al. 2018, at temperature above 900 degrees C, the area of the surface and volume of the pores reduced due to a prolonged thermal action, culminating in agglomeration. Now, on the slide, I am showing you the scanning electron micrograph image, or SEM, of calcinated eggshell. Based on the SEM image, we can conclude that there are large and well-developed pores suited for adsorption on eggshell's surfaces. The morphological view of activated carbon from the eggshell reveals irregular shape. The same image also results in an uneven structure of carbon. The calcination process enhances the surface area. The active sites on the surface area formed due to thermal effect. Mentioned by Pezzotti et al. 2016, the micropores present in the activated carbon is due to active sites, or also referred as material absorption process. Now, on the slide, this is the FTIR spectrum of calcinated eggshells. There are 2 parts in which calcinated eggshells is shown in the part A and eggshell powder is in B. In both spectrum, the peak existed at 1,404 cm is due to stretching of calcium carbonate. Besides that, one extra peak at 1,523 cm in the FTIR spectrum of calcined eggshells is because of the presence of calcium oxide. Now, let's talk about effects of pH on adsorption. The descriptions are: adsorbent dosage is equals to 200 milligram, stirring time is 1 hour, and the temperature is at room temperature. The effects of pH on adsorption was examined from 2 to 7 pH, and the adsorbent used is calcinated eggshell. Based on the data provided in figure 3, the amount of cadmium adsorbed per unit mass of adsorbent, or QE, and pH are proportional. Because the hydrogen plus ions which covered the area of the surface diminishes as pH rises, the electrostatic contact between CD and adsorbent sites becomes stronger. Now, for the effect on the amount of adsorbent, the descriptions are: pH is equal to 5, stirring time is 1 hour, and the temperature is at room temperature. As the amount of adsorbent used or calcinated eggshells rises from 50 to 250 milligram, the percent removal also increased, and it reaches a maximum at 200 milligram. The recovery for 50 milligram and 100 milligram was less than 60% and around 80% respectively, whereas the recovery for 200 milligram and higher is nearly constant at 90.5% to 92.5%. Now I am showing you the Langmuir and Freundlich isotherm model. At the left-hand side, this is the Langmuir adsorption isotherm, and at the right-hand side is the Freundlich adsorption isotherm. As you can see on the slide, the correlation coefficient or R square for Langmuir adsorption isotherm is very small when we compare it to the value of U90, which is 1. Meanwhile, for Freundlich adsorption isotherm, they are capable to estimate the metal ion adsorption by castellated eggshells because correlation coefficient or R square of Freundlich adsorption isotherm is equal to 0.92 or close to 1. The adsorption site in Freundlich have varying affinities. Thus, the places with greater affinities are filled first, and the number of adsorption sites increase as the bonding energy decreases. You can see on the tabulated data below, for Langmuir adsorption isotherm, the correlation coefficient or R square is equal to 0.8626, which is far from the value of U90, which is 1. Meanwhile, for Freundlich adsorption isotherm, the correlation coefficient or R square is equal to 0.9998, which is close to 1. In conclusion, calcined eggshells can be used as an adsorbent to remove cadmium in a simple, efficient, ecologically friendly, and cost-effective way. Cadmium was absorbed at pH equals to 5 and 200 milligram adsorbent. After 120 minutes of contact time, Freundlich adsorption isotherm was validated. As the concentrations increased up to 50 milligram, the amount of cadmium absorbed per unit weight of adsorbent or QE also increased. However, the linearity deviated. Here are the list of my suggestions for this study. The first one is eggshells has been proven as an effective adsorbent, and therefore future studies should be more on its usage in various ways. Next, the future study should provide details more on how to continuously find new ways of using eggshells, not only as activated carbon, but also as something else that related to research progress. Last but not least, researchers should find an initiative in making adsorption process more effective than it is right now. That's all from me. Thank you so much.